Hello, today I'm going to show you how to make Minecraft in Unity. So the first thing you want to do is press new, and you're going to want to name your project something original like Block Game. But I already named one Block Game because I tried to record this about an hour ago, but the audio wasn't working, so hooray for that. So I'm going to call this Block Game 2. Make sure everything else is correct, select your correct Unity version and everything, and I'm going to be using the high definition render pipeline template just because I like it. It's probably not the best template for this sort of project, but it's the one I'm going to be using because I like all the features that it provides. Alright, press create project and then wait for Unity to load. Alright, now we're in Unity after it's finished its horrendously long loading cycle. We can delete all of the assets that we have in the hierarchy view except for the player controller FPS game object. We're going to want this player controller FPS game object for our player controller in our Minecraft game. If you don't have a player controller in your template, then there are plenty of tutorials online on how to create a player controller, or you can import a player controller from the asset store. It's up to you, either way will work. Alright, now Minecraft is completely about blocks, so what better thing to start with than blocks? So go up to the game object tab and press create empty and call this game object a chunk. And if you haven't guessed by now, this chunk game object is going to be responsible for being a chunk. A chunk is just a collection of blocks that our player can break and mine and place and move around on in the world. Alright, now, our chunk needs a couple of components. So go to the right and press add component, and you're going to want to create a new script, call it voxel chunk. Press new script and press create and add. There are three more components that our voxel chunk needs, and that is the mesh collider, the mesh renderer, and the mesh filter. The mesh filter is what holds the mesh for our mesh renderer to draw. The mesh renderer draws the mesh to the screen, and the mesh collider is the collider for our player controller to stand on. Alright, now that that's ready, we can go to the voxel chunk component, click on the three dots at the very far right side and press edit script. This should open up your default IDE for editing the scripts. Alright, so I'm inside Visual Studio because this is the default IDE for me. And we have a couple of functions that we begin with, just get rid of those, we don't need them. So the first thing we want to do is create some variables for our mesh renderer, mesh filter, and mesh collider components so that we can access them quickly without having to call get component every time. So we'll do public mesh renderer, mesh renderer. We'll also do public mesh filter, and we'll also do public mesh collider, mesh collider. Now we need to go into our awake function. To produce an awake function, just type awake and press enter and it will autofill. If not, you're going to have to write private void awake or public void awake or whichever. And now we can do mesh renderer equals get component, mesh renderer, mesh collider equals get component, mesh collider, and mesh filter equals get component, mesh filter. Alright, so now we need to define the size of our chunk, and the size is how many blocks exist within the chunk. So we can do this just by doing a public int size equals, and what I'm going to be using is 16. I find 16 is a good number of blocks to be inside the chunk. Now that's not 16 singular blocks, that is 16 by 16 by 16 blocks, which makes up the entire chunk in 3D space. We also need a public short block IDs. And this is a 3D array, so do the array symbols and then put two commas inside to tell it that it is a 3D array. This is meant to be after short. So we have a 3D array of shorts, which is our block IDs. And the block IDs are just responsible for telling the mesh construction function that we're going to make which blocks to draw where. Right. Now we need a function to actually initialize this array and fill it up with blocks. So we need a function void generate blocks, and inside this generate blocks function we need to initialize our array, so block IDs equals new short, and the size is size, comma, size, comma, size. So this initializes our block IDs array as a 3D array of size 16 by 16 by 16. Now we need to make a 3D for loop, which is for int x equals 0, x less than size, x++, then within that for loop we need to do for int y equals 0, y less than size y plus plus. Then inside that for loop we need for int z equals 0, z less than size z plus plus. And now we can just make it so every ID in the block IDs array is 1. And if we assume that 0 is air and we don't draw a block for that, then that's fine. We can just do it like that. So block IDs x, y, z equals 1, which means we will draw all of the blocks. Now, just for testing, we're going to be using 0 for air and 1 for a solid block. We don't actually have block types yet, but we will add it eventually. But just for testing the mesh generation, we're going to be using it like this. Right, that's our generate blocks function done. So we need to call that within our start function. So private void start. This gets called after the awake function, but when the voxel chunk component has been generated. The awake function gets called as soon as the voxel chunk component has been generated. So within our start function, we need to do generate blocks. And now that's fine. Now we need to actually generate the mesh, and we want to generate the mesh only if there have been changes, and we want to check for changes every single frame. So we can do public bool requires mesh generation equals false, and then we can create our update function, which gets called every frame. If requires mesh generation, then we can generate our meshes. So void generate mesh. And inside generate mesh, we can do requires mesh generation equals false. So if requires mesh generation, generate mesh. Right. Now we just need to make sure that it generates the mesh on the first generation. So after we generate the block ID array, we need to set requires mesh generation equals true so that the chunk gets generated. Right, now inside of our generate mesh function, it starts getting a little bit complicated because we have to actually know how a mesh works. A mesh is a collection of vertices, indices, normals, and UVs. So if you don't know how that works, I recommend quickly reading up about how that works, but if not, then it should be fine. If you copy this word for word, you shouldn't have a problem. So let's get into it. So we need to create a new mesh. Mesh, new mesh, equals new mesh. I know, creative variable name, right? And then we have a list of vector 3s, which are our vertices. So our list vector 3 vertices equals new list vector 3. Then we have a list of vector 3s for our normals equals new list vector 3. Then we have a list vector 2 of our UVs equals new list vector 2. Then we have a list of integers, which is our indices, which is a new list of type int. Alright, so vertices. Vertices are what make up a triangle, and triangles are what makes up a mesh. Every mesh in all of existence has been drawn with triangles. Normals just defines which way the vertices are facing in the world space. So this has to do with lighting calculations. The UVs are how the textures are mapped onto the specific triangles. I'll get to that soon. And the indices are how the vertices are drawn to the screen. So it's the order in which the vertices are drawn to the screen. So the indices define which vertices each triangle uses. Alright, so now we can actually get on to generating the mesh. So we need int current index equals 0. So the current index refers to the indices. We just increment this as we draw more vertices. Now we need another 3D for loop. So for int x equals 0, x less than size. Or rather, instead of doing that, just copy this 3D for loop, paste it in, and get rid of this block IDs equals 1 stuff. Right, now, as we said, if the block ID is 0, then we don't draw anything. So if block IDs x, y, z equals 0, continue, meaning we don't draw a block. But if it is not 0, then we need to generate the block. Now we need to create some generate block functions, and we're going to have one function for each face of the block. So the first one we're going to do is void generate block underscore top, and this needs a reference to our current index. It needs a vector 3 int offset, which just refers to which area it is inside of the 3D array. It needs our list of vector 3s for our vertices. It needs our list of vector 3s for our normals. It needs our list of vector 2s for our UVs. It needs our list of integers for our indices. And it needs a rect for the block UVs. Now this block UVs rect just is referring to which texture we are selecting within the texture atlas for the block to be drawn with. So like if the block is dirt, then we'll be selecting the dirt texture within our dirt atlas. If it is stone, then we'll be selecting the stone texture within the texture atlas, so on and so forth. Now we need to actually get into generating the data for our vertices, normals, UVs, etc. And this is where it starts to get a little bit complicated. Now it's not overly complicated. If you've done it before, you can do it a million times, but as a beginner, it is fairly complicated. So assuming this is the top of the block, we're looking down at the top face of the block. We can map out some coordinates at each of the 4 corners to see where we need to place our vertices. So up here we have negative 0.5 and 0.5. Then over here we have 0.5 and 0.5. Then down here we have negative 0.5 and negative 0.5. And over here we have negative 5 and negative 0.5. Now this can be used for any face, but since we're doing the top face right now, we have to consider these as the x and z coordinates. So this is x and this is z. So using these, we can now construct our vertices. So we need to plot the vertices in a clockwise order. So we'll do it like this: 1, 2, 3, 4. So with that in mind, let's jump back into Visual Studio and start plotting those out. So we need to do vertices.add new vector 3. And let's look at our first one, negative 0.5 and 0.5. So negative 0.5, and then we're looking at the top face, so we need an offset of 0.5 for the y, and then we have 0.5 for the z, which we have mapped out in our image. Then we need to add the offset, which is calculated using this 3D for loop. Make sure all of those are 0.5f to make sure that it's a float to satisfy the vector 3. Now that we have the first vertex, we can go ahead and satisfy the last 3, which is just 2, 3, and 4. So let's do that now. So we copy that one. We have positive 0.5x and positive 0.5z. Then we have positive 0.5x and negative 0.5z. Now we have negative 0.5x and negative 0.5z. Right. Now that we have the vertices, we need to do the normals. So normals.add vector3.up. Because we have the top face of the block, we need to make sure all of the normals are facing upwards. So we add that 4 times, 1 for each vertex. Now we need to do the UVs, so UVs.add. And if we look back at our image, the top left of our texture should be here, and the bottom right of our texture should be here. So using that, with the rect that we're going to provide, we will be able to map that out accordingly. So new vector 2, block UVs.x minimum, which is our leftmost side. And we have block UVs.y max, which refers to the top of our image, which will just be up here. So we have the leftmost side with x minimum and y max is the topmost side, which will give us the top left corner. Now we need to get the top right corner. So doing that, we can do x max and y max. Then we need the bottom right corner, so we can do x max and y min. And now we need the bottom left corner, so that will be x min and y min. Alright, now that we have our UVs mapped out, we need to add the indices. The indices tell the graphics card which order to draw the triangles. So looking back at our image, this square needs to be drawn in 2 triangles. So if we divide it down like this, we have 2 triangles we can work with, and then we can define our indices just like this. So we can do indices 0 here, index 1 here, index 2 here, which defines our first triangle, which is, we need to do it in a clockwise motion so that it doesn't get culled. If we do anti-clockwise, then the triangle will only be able to be seen from the opposite side. Right, so that's our first triangle, and then we need our second triangle, so just here. So then we need 3, 4, and then 5. So we've drawn both triangles in a clockwise winding order. So now we can enter those as our indices. So our first index, index 0, is at our first vertex. So we can add that like so. Indices.add current index, which is our index we've referenced in, plus 0. So that's referring to the first vertex. Our second index is referring to our second vertex. So we can add another index and do plus 1 for our second vertex. And our third index is for our third vertex. So we can just do current index plus 2. For our fourth index, we need to use the first vertex. so we need to do current index plus 0. Then we are using the third vertex for our fourth index, so we need to do current index plus 2. And then finally, we are using the fourth vertex for our fifth index, so we need to do current index plus 3. Now at the end of the function, we need to do current index plus equal 4 to increment the current index, which is just keeping track of how many vertices we have at the moment, so we need to make sure we increment that. Now that we have our generate block top function, we can actually use it in our generate mesh function to generate part of our mesh. So we can do generate blocks top and pass in our current index. We can pass in a new vector3 int x, y, z. Actually, we can take this out. So vector3 int offset equals new vector3 int x, y, z. Then we can pass that offset into our function. Then we can give it our vertices array, our normals array, our UVs list, our indices list, and we don't have our UVs yet, so we can just type in new rect to give it a empty rect. And that's fine, but we have to pass this by reference, so reference current index. Now that we have that, we need to update the changes to our mesh, and to do that, we need to do like so, new mesh dot set vertices, vertices. We should move requires mesh generation to the very last part of the function. Right, so new mesh dot set vertices, new mesh dot set normals, normals, new mesh dot set UVs, and we need to select UV channel 0, pass in our UVs list, and new mesh dot set indices, pass in our indices list, and we need to define the mesh topology, which we're using triangles. And we are selecting the 0th submesh, or the first submesh. Now we need to recalculate the tangents. Tangents are just something to do with lighting calculations. We won't be worrying too much about those. But we do need to recalculate them every time we change the mesh. Now we need to set the mesh filters mesh to our new mesh. Then we need to set the mesh colliders shared mesh to our new mesh. And we need to, eventually we'll be able to set the texture, but we don't have a texture right now, so we'll just comment that there for future reference. Now if we jump back into Unity and press play, we should generate a chunk. Right, so as you can see, we've generated a chunk. It's all pink because we haven't assigned a material yet, but we've generated all of the top faces of this chunk. Let's just quickly assign it a material so it's not blindingly pink. So right click on assets, go to create, and then press material. Name this material something relevant like chunk. And then over on the right side of the Unity editor, we have this base map. Let's set it to something like green, just for testing purposes. Now press on our chunk game object and drag this chunk material to the materials tab of the mesh renderer component. Make sure we remove that first element. Make sure we only have our custom material as the only element in this materials list. Right, now if we compile that again, our chunk should be green with all of the top faces of all of our blocks filled in. So there you go, we have a green chunk. But this isn't very interesting, so let's make it randomly generate blocks so we have some blocks filled and some blocks not. So jumping back into our code, we can go up to this generate blocks function and surround this block IDs equals 1 in a random if. So if random.range between 0 and 2 equals 1, so there's a 50-50 chance of it being 1, then we can generate this block as block ID 1. Alright, let's test that and see what that gives us now. Alright, so as you can see, we only have half of the blocks filled in now. So that's pretty cool. However, it's not very good with only the top face filled in of every block. So let's start filling in the sides and the bottom. So going back into our code, we can just copy this generate block top function and change the position of the vertices. So now we'll generate the right side, and we need to change the offset of the vertices. So all of the x's are positive for the right side. The first two y values are positive and the second two y values are negative. Then the first z value is negative, then we have two positive z values and then a negative z value. We also need to change the normals to make sure they're all facing right, and everything else can stay the same. Now we can copy that once again and change it to generate block left, and then we need to change the vertices. All of the x values need to be negative, The first two y values positive, the second two y values negative, and then we have the first z value positive, then two negative z values, and then a positive z value. Now we can do generate block front or forward, change the normals to forward, make sure we change the normals for the left to left as well. Alright, so the vertices in forward are positive, negative, negative, positive for z, then positive, positive, negative, negative for y, and then all of those z values are positive. Alright, now we can generate block back. So the back has all negative z values, 2 positive y and 2 negative y, and then a negative, a positive, and a negative for x. And of course we change our normals as well. So now we've done top, right, left, forward, and back. The last one we need to do is bottom. So generate block bottom, change the normals to down, and our vertices need to be negative, positive, positive, negative for x, all negative for y, and then 2 negative and 2 positive z values. Right, now we can move all of those functions into our generate mesh function. So copy top, change it to right, copy that one, change it to left, then forward, then back, and then bottom. Now that we have that, let's jump back into the Unity editor and see what that looks like. Alright, now as you can see, our chunk is fully featured with faces on all sides, so that is pretty good. That's a pretty good start. Now if we move our player controller to land on top of the chunk, we should be able to walk around on top of it. So change the position to 6x, 6z, and 20y, and press play. And now we have our player controller who's able to walk around in this chunk. Now this player controller doesn't seem to be able to jump, which is fine, but we can walk around in our chunk, and yeah, we're currently stuck in a hole, which is not ideal, but as you can see, we have a chunk, we have blocks, and that's a good start. I'll leave it there for this video. In the next video, we'll get onto texturing and placing and breaking blocks. If you like this video and you want to see more of this tutorial series, let me know in the comments. As always, be sure to like and subscribe, and I will see you next time.